scalar formation. What is the moment? For example, in this figure, when we push the push force to the winch, the point O will get the moment. The tendency to rotate is called the moment of force, or total moment. Sometimes we call torque. And the shortly distance from the force direction to origin, we call perpendicular distance is called moment arm. So when the force direction like this moment arm, like this, the moment arm not D, is D plus. And here, because we use the perpendicular distance, when the force direction like this, the moment arm is equal to 0. So the mean is no rotation upwards, indicate this point no moment. So this formula used to calculate the moment in scalar formation. The moment is equal to the force times the moment arm. So we use the force times the moment arm, we can get the moment. And the unit is equal to Newton times meter. Then the moment actual is defined as the line. Moment actual defined is as the line. We call a perpendicular to the plane, then containing the force F and the moment on D. So please note that the moment follow the right hand rule. So you need to use your right hand. The direction of the forefinger represented the direction of the applied force. So we use the forefinger applied force here. Then the direction of the stem represented the moment actual. So in the page like this is the force. Then we use the forefinger from this to this. So the moment actual out of the page. Okay? So if the force direction from this to this, the moment actual into the page. Okay? This is a formula for the resultant moment. If we look at the moment on this page, like this figure, the first one here, so use your forefinger from the applied force, then the moment actual out of the page, then we call this moment is on counterclockwise, then the mean is a positive moment. This is positive moment. So the F3, force 3, also like this. So this is positive moment. And the F2, you can see the force direction like this. Then so the moment actual into the page. And the moment is clockwise, so we call this is a negative moment. Then if this is a static system, we can summary every moment together like this. So F1 is positive, F2 very easy example. Just calculate the moment. For each case, elastic in this figure determine the moment of the force about the point O. So we have the applied force at here, and we want to determine the moment. So we need to get the moment arm. So this is force direction. Then we can get the perpendicular distance from O to force. So the moment arm is 2 meters. So if you want to get the moment, you just use the force times the moment arm. So the answer is 200 newtons meter. And carefully, sometimes we use the mark. Sometimes we use the mark. The mark means clockwise moment. So if you don't want to use this mark, just put the minus from this. Okay, so you can see the force like this. So the moment is clockwise. The moment actual into the page. Then we can get the negative moment. Okay. This is 4 other example. So we can see the first one, figure B. The force put in here, so we extend the force direction like this, and we can determine the moment arm from O to force direction. So the moment arm is equal to 0.75 meter, not 2 meter. So we use the force times the moment arm, then we can get the moment like this answer. And you can try, this is also negative moment, because the moment will clockwise. Okay, now we talk figure D first. Then you can see force at here, force direction at here. So we extend the force direction. So the point O to force direction, the distance is equal to 1 times sine 45 degree meter. So we use the force times the moment arm. We can get the answer here. And carefully, this time the force is here. So your forefinger from the force and the moment actual out of the page, and the moment is counterclockwise. So this is a positive moment. Okay. In figure E, we can do again the force at here. The force direction we can extend to this. Then we can see the moment arm, or we could call a perpendicular distance, is 4 meter minus the 1 meter. So we can use the force times the moment arm like this and get the answer. And it is also forefinger is force direction. So this is counterclockwise. So the moment is positive moment. And about figure C is a little different with other figure, because this have a support, but we also can calculate the moment and conservate. So we have the force at here, and we extend the direction, force direction, and we can get the distance from O to force direction. The moment arm is equal to 4 plus 2 times cosine 30 meter. So we can calculate that this and get the moment, and this is negative moment. And maybe some students wonder, since is supported here, why can we still directly calculate the moment? Because in the static state, the object remain motionless, and the force at every point are equilibrium, so we can calculate directly. This is other example. Determine the resultant moment of the four force acting on the road. So we want to determine the point O moment. We have the four force, one here, and one here, and the other two here and here. So we just try to find the moment on in this project. So first, use this. The moment arm, I think, very easy to find. Is equal to 2 meter. And carefully, this force is okay. This force for point O is negative moment. So we put a negative minus here. Then we want to find this part. Okay, 60 Newton. But the force direction facing the point O, so no moment here. So you can see no moment on, just times 0. Then we find this force. So we extend the force direction, then we can get the moment arm. Use 3 meter times cosine 30 times sine 30 degree. And carefully, for point O, this force is positive moment. For final force, if we know we can try just negative moment and use the 40 Newton times the moment arm. And the moment arm, how to calculate? Just 2 plus 2 plus 3 times cosine 30 degree meter. Then we can get the answer is negative moment. So you also can use this type to do your answer. Okay, now let's move on the cross product. The cross product of the two vector A and B yield the vector C, which is written as like this. We read this is C equal A cross B. C equal A cross B. The magnitude is C equal A times B times sine theta. The theta between from 0 to 180 degree. And the cross product follow the right hand rule. So first one, curling the finger from the A to B. So we call the A cross to B. We can get the unit vector C. Then the same point, the direction C. unit vector C. Then if you want to calculate, just use this equation. C equal to A plus B equal to A times B times sine theta times UC. The UC is unit vector on the direction of C. Okay, when you use the cross product, please note some law of operation. First is commutative law is not valid. The meaning is A cross to B not equal to B cross to A. We can see this figure from A cross to B, the C direction, like this figure. And if you use the B cross to A, the C direction like this, so it's different thing. If you want to use A cross to B, B cross to A, please put the minus here. The second is multiply by the scalar, the associative law. The meaning is alpha times A cross to B is equal to alpha times A cross to B equal to A cross alpha B, alpha times B is equal to A cross B times alpha. And the third is distributive law. The meaning is A cross B plus B equal to A cross B plus A cross B. So carefully these three operation laws, and overall the cross product must be maintained because we are not commutative. Okay. And in Cartesian vector formulation, we also use the C equal to A times B times sine theta on the page of the Cartesian unit vector. The mean is x direction just use the I, and the y direction use the j, and the z direction use the k, and the I cross to j, the mean is we can get the k. And because this is a unit vector, so the value is 1, 1, 1 times everything also equal to 1. Then we can get the positive k. Okay, like this. So we can use this figure to let us can remember I cross to j. Okay, I cross to j. I cross to j equal to k, and the k equal cross to k is minus j, and the I cross to I just 0. So use this picture. I think it's very easy to remember. So use also like right hand side row or right hand row. So from I to j is counterclockwise. Then we can get a positive moment like this. So I cross j get the positive k, but from k cross j we can get the negative I. So very easy to remember this part. Okay, so if we use the A is a vector, B also is a vector. So if we use A cross to B, the equation like this. And you can see when we use the A equals to B, just use the times this part. AX times BX and I cross to I. Okay, so this first item, AX times BX and I cross to I. And also use AXI. We want to cross at here, BYJ. So AX times BY here, I cross to J here. So we can do like this. So we can get the equation. But you can see I cross to I is equal to 0. J cross J also equal to 0. And K cross K equal to 0. So nothing in here. Okay. Then I cross J is a positive K. So you can see the K part have the AX BY item in here. Okay, so do some massage, you can get A cross B equal to this equation. But I think this is very highly calculated process. If we have to calculate like this every time using the Cartesian vector formulation, it would be really troublesome. In addition, memorizing the formulas directly is also quite exhausting. We can use the determinate form. We can use a determinate form. If you want to calculate the A equals to B, just put the Cartesian vector I, J, K at here, and the A vector value at here, and the B vector value at here. And if you want to calculate I part, just use the AY times BZ minus AD times BY. So you can see. So we can get the I part the value. Okay. If you want to get the J part just like this, then use the AX times BZ and minus the AD times BX. But don't forget, because have the section at here, so we need to put the negative sign at here. Okay. If you want to get the K part and do like same concept this I part, we can get the K part value. Sometimes in Taiwan we don't remember this because we just move this current, to this. So we just use the AZ times BX minus AX times BZ. So you can see the same answer here. Okay, and this is a formula used to calculate the moment in vector formulation. The moment is equal to the vector R cross vector F. Okay, so use the vector R cross vector F. The R represents the position vector from the point O. So from point O to the force vector, we call this is position vector. So any point on the line of the action of the F direction is okay. So like this, O from O to A, this direction, this vector we call the position vector. From this point to this point, also can call the position vector. It's okay. Okay, then how to calculate the moment, the value. We use the moment equal to r times f times the sine theta. The theta is the angle measured between the r and the f. So we just extend the vector r in here. So r cross to f. So r cross f. So the theta at here. Okay, not at this position. Just use this because r goes to f. And as in this figure, it's very simple, very easy to calculate the moment. If the force is here, we have a perpendicular distance at here, so it's very easy to calculate the moment on the point O. Just use F times the moment on D, we can get. And if you want to use the vector to calculation, also like this. So r cross f is equal to r times f times sine theta, and r sine theta is equal to d. So every position to the position vector r is okay because the r from this to this, the perpendicular distance no change. Okay. So moment no change. Okay, so let's summary this example. Direction and the resistance of the moment and determined by a right-hand rule. Carefully extend the r vector to the dashed position. Okay, from this to this. So extend. Then curve finger from the vector r to f. Okay, so use a forefinger from r close to f. So the moment direction is same as the direction of the step. Maintain the proper order of the r close to f. Since cross product is not commutative, okay, so we just use the r close to f, r cross f, not f cross r. Okay, this is I call this is a principle of transmissibility. We can see the moment is equal to every r vector cross f. So if the force vector is same, okay, fixed at here, any r vector is okay. Don't worry about the calculation. Then f can be applied at any point, okay, any point, create the same moment about the O, and the f can be considered a sliding vector. Okay, so if you use the Cartesian vector formula to calculate, you can use the determinate form like this. So just put the ijk here and the r vector value here and the force vector value here. Then you can calculate, okay, again the accuracy. If you want to get the I part, just use this times this minus this times this. Okay, so very easy to calculate. So we can get this equation. If we use the Cartesian vector formulation, the moment is always perpendicular to the plane containing the vector r in the F. And about the resultant moment of the system of the force, for example, the resultant moment at the point O in this figure would be determined by the vector addition of the moment of each force. So each force we can calculate the moment back later. Okay, this is very simple. The determine the moment product by the force F in this figure about the point O express the result as the Cartesian vector. So this is tree, and we have a point O, and here we want to determine the moment point O. Then the force from A to B is the force direction. So first one, we need to find the position vector r, right? So the O to B is position vector, and the O to A also is position vector. So you can use O to A. O to A. So the vector is 12k, because the I and j is 0 from O to A. So RA is equal to 12k. If you use the O to B, I think the x is 4 and the y is 12, and the c direction is 0. So the RB vector is equal to 4i plus 12j meter. Okay, so we have two position vectors to calculate. Then in the force, we use the force times the unit vector, because we use the Cartesian vector form. So we need to find the vector first from A to B. So the vector is x direction is 4, and the y direction is 12, and the z direction is minus 12. So you can see this is a vector at here, and this is the vector distance here. So we can get the F equation. Okay, so we do the determination form. First one, we will use a position vector RA. So RA cross F, we put the determination form IJK, and the RA is 0012, and that like this. Then we can get the I part, right? We want to get the I part. Use the 0 times the minus 1.376, and minus the 12 times the 1.376, and here this is I part. Then we want to get the J part. Don't forget we need to put a negative sign in here. So we use the 0 times the minus 1.376 minus the 12 times 0.4588, and here is J part. If you want to get the J part, just do again. But we can see 0 times this, 0 times this, also the K is 0. So we can get the answer at here. Okay, so I think use the position vector RB also like this constant. It's very easy. Just put the IJK and the RB vector value and the force vector value in here, and do again, and we can get the answer. But you can see the answer is same. So if you want to calculate the moment on the point use the force F. Use the RA, it's okay. Use the RB also, it's okay. This is other example. Two forces are on the road showing this figure. Determine the resultant moment they create about the flange at the point O, expressed in the result as a Cartesian vector. So we know we have the two force, and the Cartesian vector here. We want to calculate the point O moment. So first we want to find the position vector. So for O to A, we call it RA, and O to B, we call it RB. So O to A is on the y direction. Then the distance is 5 meters. So RA is equal to 5j meter. And the RB from O to B. So from this to this, the vector is x direction is 4, y direction is 5, and the z direction is -2. So the RB is equal to 4i plus 5j minus the 2k meter. Okay, then we can put the R cross F. So RA cross F1 plus RB cross F2. Use a determination form like this. So we can calculate again I par, J par, K par, I par, J par, K par, and we can get the answer. Okay. Let's move on to the principle of the moment. Is follow the this theory. The moment of the force about a point is equal to the summary of the moment of the component of the force about the point. So force can equal to force 1 plus force 2. So the moment also can do like this. In this picture, I think it's very easy to calculate the moment. If you have the force F at here, just times the moment distance d, we can get a moment about the point O. We also can use Fx, times the distance x, and the Fy times the distance y. Also can get the same moment. And so why we introduce the cross product, you can think about it, and the example later will provide the answer. Okay, so this example determine the moment of the force about the point O. So we have the force here. So if we use a particular distance, I think it's very easy to calculate the moment. Like the distance, we can use 3 meter times the sine 75 degree, and we can get the distance, perpendicular distance, and use the force times the perpendicular distance, we can get the moment. So this is very easy, simple. But we can use other function to calculate. Okay, if we let the force divided to the force y and force x, so we can use the force y times the distance y, and force x times the distance x. So you can see the force y times the distance is equal to 3 sine 30 degree, and force x, force y times the distance y is 3 times cosine 30 degree meter. And don't forget right hand rule. So these two forces, then the moment is negative. So that is, you can see. And this is other example. The force at the end of the angle bracket in this figure determine the moment of the force about the point O. So we have the force at here, point O at here. So we also can very easy use the scalar analysis method to do this. So we can get the we can calculate the moment arm very easy, and use the force times the moment arm, and get the answer. Okay. So we can use this force divide to this direction and this direction. So we can get the moment answer. We also can use vector analysis. So I think it's very more calculation in this part, but just try. Okay, we just try. So we need to find the position vector r from O to first point. So the x is equal to 0.4 meter, and the y direction is positive direction, is equal to 0.2 j. So this is positive vector, and the f direction also like this. So we can use the sine 30 degree times the force and use the cosine times the force. We can get the x direction and the y direction, and we can get the vector f. Then use the moment equal to position vector cross a force vector. Just put the I, J, K and the position vector value and force vector value here. Then use the determination form to calculate again, and we can get the answer. You can see the answer is there. The answer is here. The answer here is there. Okay, so it is like the scalar analysis provides a more community method of analysis and the solution 2 since the direction of the moment and the moment arm for each component force are easy to establish. Hence, this method is generally recommended for solving a problem displayed in the 2 dimension. Whereas Cartesian vector analysis is generally recommended only for solving 3-dimensional problems. Okay, so this is the answer. Okay, so now today we finish the class here. Thank you.